Manuel, by the way, is the maintainer today of the Nginx ingress controller in upstream Kubernetes. So anyway, so thank you, Manuel. Round of applause for it's good to finally come to Chile and meet. I did think I promised you at one point that I would come shake your hand. Okay, so I think around the prior art, the point that I'm trying to make here is that what was the thing that was wrong with? Oh, sorry. What was the thing that was wrong with Heroku and what was wrong with Cloud Foundry? That for everything that was good. The thing that was wrong with it was that the minute that abstraction failed you, the minute that 12-factor PaaS stopped working, you had to fall all the way down to virtual machines, right? There was no intermediary step. And falling down to VMs that you have to manage with Chef and Puppet and VM orchestration tools is very painful fall. And there's a lot of applications and workloads that can't fit strictly in a 12-factor sense. And so the way that I like to look at this was what I call a black box abstraction, which is you can't see beneath it, right? There was things like Kubernetes and orchestration powering these systems. For example, Cloud Foundry has a system called Diego that they use to schedule the workloads inside of Cloud Foundry. But Diego is not designed to be used directly, right? It doesn't have the same sort of appeal. So one of the things that we did with the next version of the Deis PaaS that we built was we decided that we were going to platform it on top of commodity orchestration systems like Kubernetes. And the idea here was that when the abstraction of the PaaS failed you, right? When 12 factors stopped being a good idea, you could drop down just a little bit to the Kubernetes API, run your app that needs to not be 12 factor there, but it could still see and talk to the other apps that were being deployed in 12 factor, right? And so you could use Kubernetes Service Discovery to talk natively between apps, whether they were deployed natively through Kubernetes or through tools like Helm, which we developed while we were at Deis, or through the sort of PaaS abstraction. And I think this was a really important model for us. But it was interesting because we actually built it in such a way where the orchestrator was pluggable. You could use Mesos, Docker Swarm, or Kubernetes. And we actually ran like that for a little while we waited to see what the market did. And so what did the market do? Well, no surprise. It shifted very quickly, very rapidly towards Kubernetes. And I actually remember Manuel was very vocal proponent of us going more towards Kubernetes. Lots of customers that I was talking to were very vocal about moving towards Kubernetes. And so we decided to just sort of say, like, look, the other paths are deprecated. We're going to choose to focus on Kubernetes. Now, interestingly, in this model, because we were building a very, very complicated system, lots of different microservices doing source to image and unclustered builds and complex routing. We had more knowledge of how Kubernetes worked 2-3 years ago than just about anyone did in terms of sort of the software and production stack. So I started getting calls to consult with some of the largest Kubernetes deployments in the world. Not necessarily using Deis, but just on Kubernetes because we knew more about it than a lot of people. And so I actually worked on OpenAI's Kubernetes infrastructure, which was the largest Kubernetes cluster at the time, 2,500 nodes to do machine learning model training using TensorFlow. And so very interesting case. I also worked on Mozilla's infrastructure, Kubernetes-based infrastructure. And I learned a lot during this period, but probably the most important thing that I learned was that when you start using technologies like Kubernetes, it's really not so much about the technology at the end of the day, and it's really about what the technology does to how you structure the operations function inside of your company. And now, if you're a small company, this won't be relevant, right? If you're just a startup, you're doing everything, and good luck to you, right? I did startups too. I also did everything. If you're a large enterprise and you have lots of people that are doing operations, you're going to derive something like this model. Let me explain how this works. At the bottom of the stack, you have infrastructure operations. Infrastructure operations is responsible for racking and stacking compute, network, and storage. typically raw, could be physical, but could also be IaaS, right? Cloud-based IaaS. And that's their job. And ideally, you get people who, that's all they do. They manage capacity, they monitor the infrastructure, they make sure it's always available, and they provide a service and an SLA guarantee on that info. The next thing you will derive is the need for what is called a cluster ops team or a platform team. And the platform team's job is to assemble the compute, network, and storage into a set of cluster APIs that can be used by software teams that abstract away the underlying infrastructure. But it turns out that that's actually, it's a whole job in and of itself. How you build a platform, how that platform evolves over time, what kind of tooling decisions you want to provide to your software customers, right, who are going to be running on top of that platform. Turns out this is a really hard job, constantly evolving. The technology is always changing. And then at the top, you actually have another set of operational concerns. How are you going to manage your CI/CD pipelines for your app? How are you going to manage telemetry and monitoring and alerting? How are you going to do canary releases and feature flags for the application level? And that's actually not something that the platform people should be worried about. Maybe they can provide opinions and best practices, but at the end of the day, it should be up to the people who are writing the software to determine those things at the top level. So in other words, what you need is you need to segment. You need a specialization of responsibilities at the different operational tiers. And when you start to use Kubernetes, you will, at a big company, you start to derive this. It will happen naturally whether you want it to or not. Now, I just want to point out that not all of us get the luxury of having this nice, clean operational structure. Many of the people that I work with have the poor job of doing all of these at the same time. They rack and stack servers in a data center. They glue those servers into something resembling a cluster. Then they're responsible for loading operating systems and workloads on those. Then they're responsible for monitoring all of it. All the way apps, OS, infra, networking, all of it. And then you say, oh, we're going to do this new Kubernetes and container thing. And they go, oh, why would I want to do that? My job sucks, right? This is so hard. And you're like, no, it's going to get better. Trust me, it's going to get better. They've been told that a few times, and it hasn't gotten any better, right? So I feel bad for the people who are stuck trying to do all this. But I think the biggest takeaway for me, the biggest learning for me was that it's important to separate responsibilities. I know this does not align with the traditional DevOps model. Right? I think the DevOps model, I don't know what it is, right? But like, people talk about it like, all right, well, everyone's going to get in a room and you grab some beers and it's going to be great, right? Trust me, it's going to be awesome, right? I don't think that's how this works, right? I think what ends up happening is you need to provide APIs, you need to provide interfaces between different amounts of what is software, really, at the end of the day, right? And so I think the closest thing to classical DevOps is probably that top tier of application ops. The people who are writing software need to know how to operate their software. We can all agree that that's probably a good idea. And that's where I think the idea of DevOps comes in. But if you ignore the bottom two layers, you're really missing the point. Ultimately, this comes down to something that I believe, which is that if you build it in software, you run it, right? I know this isn't always possible. I know this isn't always popular. But I firmly believe, this is what we do in Azure, right? Every team in Azure who builds a service is responsible for operating that service. If it breaks because it's garbage, you get paged, right? And I actually think that the incentives align nicely if that's the case. So I want to talk a little bit about some of the practices that I see around what I've learned operating or seeing all these container deployments at scale, helping customers. So let's start with version control. Obviously pretty central. So who here has heard of the term GitOps? Who here has not heard of GitOps? Okay. So the idea of GitOps is a very simple idea. It basically states that you want your operations, IT operations, really that whole three-layer diagram, or 3 layers of ops, to be stored in version control so that you have a system of record where it's all tracked. But more importantly, you get to have conversations over a pull request when you make changes. So if you're using GitOps, not only do you get the system of record and do you get a nice CI/CD pipeline for rolling out changes, you also get a change control system for free, which is around a conversation around pull request. Do I merge this or not? Do I change the replica count from 5 to 10? Oh wait, I never tested it with 10. Okay, well then maybe we shouldn't change it to 10. Okay, stop, don't merge the PR, right? Very, very helpful. Now there's two patterns that I see in the wild for how GitOps is deployed. There isn't a right or wrong answer. This comes down more to how your team is structured. The first is an ops-centric repository. This is where you have one repo or maybe a set of repos, and there's no code in the repos. It's just YAML that models your environments. So maybe you have a staging repo, maybe you have one repo that models all your environments. But basically it's a bunch of YAML, Kubernetes manifests, Helm charts, whatever it is in that repository. And all of the software that it uses is managed by reference to the container image. So in the specs you'll point to, so if you want to bump from one version of a container to the next version of a container, you'll go in and you'll put in a pull request on that repo to change the container image field, have a discussion about it, hopefully test it, merge it, and then it will get deployed out to production. Now, this model works well where you have sort of a throw it over the wall model, where software engineers are not, they don't understand how to build and deploy software. In other words, if you're not really using you build it, you run it, and instead the software team builds it and the operations team runs it, this is probably the better approach. But you still want to use GitOps. You still want to make sure that that stuff's in version control. The approach that I tend to prefer, this is what we typically do, is we have an application-centric repository where we store our configuration, our manifest, Helm charts, things like that, next to the source code. And what this typically means is that you will have a branch per deployment model. So you might have a branch for staging, a branch for production. And when you want to make a change, you will actually merge code into the production branch. And then you can have a discussion on a pull request. I want to bump from 5 replicas to 10, or I want to change from a deployment with a fixed set of replicas to a horizontal pod autoscaler. Here's the PR that does that in production. Let's talk about it. Looks good, merge it, it deploys out to prod. But it sits next to the code. And I think what's nice about it having it sit next to the code is that the software developers who write the app can see it. It is part of their day-to-day work environment, right? Whether they were asked to write it or not, developers are curious. They're going to try and learn about what is in there. They're going to read the docs. They're going to figure it out. And you can get to a place where people can start to pick up and learn at their own speed. And ultimately, hopefully, get to a you build it, you run model. Related, I want to talk a bit about scaffolding. Scaffolding is, the idea of things that you need to land, files that you need to put inside of a version control repository to get people productive. There tends to be two patterns for this. The first is detection heuristics. So this is where you may have a software program like a draft from Azure, scaffold from Google, there's a couple other ones that are out there. But what it will do is the software will look at your source repo. It'll say, oh wait, this is a Python application. I've seen this before. And it will create a Docker file and maybe a Helm chart or a Kubernetes manifest inside of your repository. So it looks at the code, picks what the app is, and then writes out it basically helps containerize it through source control. Now, this is important because often developers don't want to learn Docker, don't want to learn Kubernetes concepts, but they're being asked to deploy to them. So how do you land code in the repository that is possible? That's one option. The other option is you have basically a set of repositories that have a default file system layout. And this is something that I tend to prefer. This is what companies like Spotify and others who I work closely with are using. This is the idea that you have like a set of GitHub repos or repositories that have like an example application in it that's a real app. So the one I like to use is a Java Spring app. So here's how the platform team at this company does a Java Spring app on Kubernetes. And what the developers have to do is they fork the repo, they clone the repo, and then they follow the README to turn that repo into their version of the app. Insert code here. And that's all they have to do, right? And everything is in the repository. Now there are downsides. You have configuration drift as you change the default repos over time and things like that. But this tends to be pretty empowering, and again, has the benefits of allowing the developers to learn at their own speed. The trick with this, of course, is that you want some sort of centralized management around how the platform team, the cluster operations team, is providing guidance to developers. Because if you don't provide that guidance, and everyone has to go learn Docker, Kubernetes on themselves, for themselves, a lot of these efforts wind up being a failure when you start dealing with mainstream development. Next thing I want to talk about is the development process, the software development process. Another thing that I learned at Microsoft is that we have entire division devoted to building developer tooling. It's called Developer Division. And in Developer Division, what they do is they build Visual Studio Code, debuggers, language runtimes, .NET framework, the .NET CLR, the TypeScript, right? Developer Division does lots and lots of work with languages and with developer productivity. So they know the mind of a developer like no one else. And when I first joined Microsoft, I started having meetings with these folks, and they taught me a lot of things about the development process, but there's one thing I want to share with you, and that's the concept of inner loop and outer loop. So outer loop refers to the period of time when a developer is writing code, but after they commit the code to version control and merge it to a mainline branch, right? Let's say you merge code into master. Your outer loop is now triggered, and your outer loop will typically be a CI process that might check out code, build it, test it, create some artifacts, publish those artifacts, maybe do a deploy, right? That's the outer loop. And actually in Kubernetes land, there's lots of tools. There's too many tools, really, for how to do outer loop. You can use Jenkins X, you can do Azure pipelines, you can use Circle CI, Drone, Spinnaker, blah. I mean, it goes on forever. There's hundreds of these tools. This is a solved problem, we put it that way, largely solved. Inner loop is different. Inner loop is the period of time where developers sitting down with hands on keyboard, they're working on a change, be it a bug fix or a new feature or something. And they're not ready to commit and merge to a branch yet, because they need to test the change in the context of the broader environment. And as you start to build microservices and more complex distributed systems, it becomes really challenging. How do you know that you're ready to commit? Because most people today who are building, let's say you have, customer I was talking to just